I made a video a while back about water hammer, a hydraulic phenomenon that can lead to major problems in pipelines. Then I did a video on steam hammer, a somewhat related phenomenon associated with steam piping systems that can be extremely dangerous. And then I did a follow-up to the water hammer video talking about transient vacuum phenomenon that can collapse pipes if they're not designed and operated correctly. But even after those 3 videos, it turns out I haven't told the full story. Because even though water hammer is generally a problem for engineers, it turns out there's a way to take advantage of this normally inauspicious effect for a beneficial use. Hey, I'm Grady, and this is Practical Engineering. On today's episode, we're talking about hydraulic ram pumps. This video is sponsored by NordVPN. Visit nordvpn.com/practicalengineering to get 81% off a 3-year plan. More on that later. A hydraulic ram is a clever device invented over 200 years ago that can pump water uphill with no other external source of power except for the water flowing into it. No, it's not a free energy device, but if you search around, you'll find lots of great implementations of this style of pump on YouTube, mainly from people doing homesteading and off-grid lifestyle vlogs. And it's easy to see why ram pumps have such popularity among these groups, because if you've got a piece of land with an abundant source of water, a ram pump lets you get that water to a tank or a location at a higher elevation with a really elegant design that requires no electricity or fuel and only 2 moving parts. So of course, I built my own so you can see how it works. But first, we need to build just a little bit of foundational knowledge on the behavior of fluids, and this is something anyone can understand. There are 3 types of energy that a fluid can have, and in civil engineering, we normally convert them to their equivalents as the height of a static column. This distance is called the head. Understanding the energy in a fluid is how we solve a lot of engineering problems, because in most scenarios, the amount of energy stays the same, and the only thing that changes is what form it takes. The first type is head from gravitational potential. It doesn't have an equivalent static column because it is a static column. The head is just the distance from an arbitrary datum. This one is easy to understand with a tank and a tube. I can move this tube around wherever I want, but the level in the tube and tank are always going to be the same. They're both exposed to atmospheric pressure at their surface, and they're not moving, so there's no velocity. It's just pure gravitational potential. The second type of energy is pressure head. In this case, the head is the pressure divided by the gravity times the density of the fluid. So if I close off the top of my tank and add some air pressure, the level in the tube goes up. The new height is the pressure head, the equivalent static column related to the pressure in the tank. For a given pressure, a denser fluid like mercury will have a lower head compared to a lighter fluid like water because they have different unit weights. A good example of measuring pressure head is a barometer. We live at the bottom of an ocean of air, and we like to keep track of the air pressure down here. One of the easiest ways to do that is to measure how high up the pressure can push a static column of fluid, in most cases mercury. The final type of energy is velocity head, which relates to a fluid's kinetic energy. The conversion for velocity head is velocity squared divided by 2 times the gravitational acceleration. I can demonstrate the equivalent column of water using a tool called a pitot tube. That's a lot of background, but it's important in understanding the function of a ram pump, because without an external source of power, even though you can go from one type of energy to another, you can't get more energy out than you had at the start. For example, I can convert a static column of water to one with some velocity, but I'm never going to get the fluid to a higher elevation than where it started, with one exception. An exception that the hydraulic ram pump takes advantage of beautifully. A ram pump is essentially just 2 one-way check valves, one called the waste valve and the other called the delivery valve. To get it started, you just momentarily open the waste valve to allow water to flow. After that, it's working on its own to pump the water uphill above the elevation of the source. Pretty amazing, I think. Let's walk through the path of the water to understand how it works. First, as the waste valve opens, water flows into the pump and immediately out the valve. But as it picks up speed, the flowing water eventually forces the waste valve to slam shut. Now the water is stopped in the pump. It had kinetic energy, but now it doesn't. That means the kinetic energy was converted to something else, in this case, pressure. This is the definition of water hammer. Slamming a valve shut converts all the kinetic energy nearly instantly, creating a huge spike in pressure that can lead to stress and damage in pipe systems and connected equipment. In the case of the ram pump though, that spike in pressure has a different effect. It opens the second check valve and forces water entering the pump into the delivery line. As you can see from my digital pressure gauge, this process is cyclical, pumping some of the water and wasting the rest each time the valve slams shut. You can see what's happening here in real time. The pump is robbing some of the kinetic energy from the flow and imparting it to a smaller volume of water. It's a redistribution of energy, converting low head and high flow into high head and low flow. And this type of pump can really create a lot of head. I ran my discharge line up to well above the roof of my shed, and my pump is still able to get the water up there. Sometimes an air chamber is included in the pump to smooth out those sharp spikes in pressure and provide a more even flow rate out of the delivery pipe, reducing wear and tear on the pump components. If you think in terms of modern electrical devices, imagine we installed a hydropower turbine on a pipe to spin a generator and then use that electricity to power a pump to move the water coming out of the turbine. Obviously, you wouldn't be able to pump all the water, and anyway, that would be a pretty complicated setup for something the ram pump can do with a few very simple off-the-shelf plumbing parts. In fact, there is a type of pump that works from a water-powered turbine. Maybe I'll build one of those next. For now though, I think the ram pump is an ingenious way to take advantage of the properties of fluids. We all need water for a variety of reasons, so being able to move it where we need it without any fancy equipment or external sources of power is a pretty nice tool to have in the toolbox. My privacy and online security are really important to me. I don't want my identity stolen, and I don't really trust my internet service provider to be a good steward of the data that they collect about me. I know most major websites are already encrypting traffic, and many smartphones do the same. I know the metadata my ISP collects is probably benign. But here's the thing. As painful as this is for me to admit, there's a lot about the internet that I don't understand. And unfortunately, a small portion of the people and organizations who do understand it actively use it to try to take advantage of the rest of us. And that's enough reason for me to always use NordVPN. New vulnerabilities are discovered online all the time, and I like the comfort of limiting mine and my family's exposure to them as much as possible, especially because NordVPN makes it effortless. I just load the app, click connect, and it's done. There's no limit on bandwidth, and it works on all my devices. If you only use websites and online services that have their own encryption and you trust your ISP with your browsing data, that's awesome. It's not true for me though, and if it's not for you, NordVPN is offering an awesome discount to fans of the channel. Visit nordvpn.com/practicalengineering or click the link in the description below to get 81% off a 3-year plan. Plus, when you use the code Practical Engineering, you'll get 4 months free and the NordPass Password Manager app. Thank you for watching, and let me know what you think.